morning, ladies and gents. This is our week number 7 online learning. Now, in this week, we are just pulling everything together in acid and base. We learned quite a lot. There's a lot of information we processed in the last couple of weeks, and we're just going to put it together and prepare you for assessments. So just to let you know, I'm looking at putting 2 assessments for you guys. The first one will be a short little quiz just about acid and base. Okay, it will be a multiple choice, pretty easy. You'll see the answers straight away, and the main aim of it is really to kind of give you an idea if you got it or you didn't get it, and if you didn't get what you didn't get, so you can improve. And then the next assessment will be more of a big test, 40, 50 marks, like we do the one in the class, and that will include acid and base, but also ions and balancing equations, and a little bit of investigation skills that we haven't done for a while, okay? So I will be in touch on the WhatsApp and on the OneNote to let you know when this is going to happen. Right, so acid and base, yeah, so what we're going to do in this lesson, and it might actually take us 2 lessons, is just to recap the chemical reactions, okay, that involve acid and base, okay? So there's actually only 3 reactions. Okay, 3 reaction, you maybe can say 4, I'll make sense in a second. So the first reaction we had a look at was acid and a metal. Okay, we mix acid and a metal. Okay, what we got is gas, hydrogen gas, okay, and a salt. Okay, salt is basically a general name of a compound when a metal and a non-metal combine together. Okay, so in black I wrote the general reaction, in red I wrote a simple example. So hydrochloric acid plus magnesium, we got the hydrogen, the H2, and the salt was made out of the magnesium and the chlorine. Okay, so the metal and the chlorine, the non-metal, always hide within the acid. That's for all 3 cases. The non-metal is always within the acid, magnesium chloride. Now, in this video, I'm not going to explain why this is MgCl2 and not MgCl or Mg2Cl or Mg3Cl2. If you don't know why I wrote MgCl2, and if you don't understand all the rest of these ions, you need to go back to, I don't know what week it was, week 4 or 5, where I'm talking about ionic compounds. Okay, we spent about 2 weeks on that, and it's a big thing. Okay, so have a look at that. We also did a little assessment about that. Okay, if you don't understand that, look at these videos. If you're still not happy with that, call me and I'll help. Not a problem. Okay. Second reaction was between acid and now alkaline, okay, or base. So this was just acid. There was no base here. Those 2 are reaction between acid and base, and they are in fact called neutralization. Can you see if I write down here? Neutralization. These are neutralization reactions between acid and base. Just a neutralization. Okay. So acid and a metal oxide or hydroxide. So we've got 2 possibilities. Either we're reacting the acid with metal oxide or hydroxide. They're both bases. Okay? In either case, what we're going to get is water plus salt. So instead of hydrogen and salt, we're going to get water and salt. Let's look at the examples. So sulfuric acid, H2SO4, plus metal hydroxide, sodium hydroxide. OH is a hydroxide ion. So NaOH is metal hydroxide. That will give you water, H2O, and the salt. The metal always comes from the base, okay, Na, and the non-metal always, as I said just a minute ago, always hides somewhere in the acid. So Na2SO4. Again, why is it 2 and not? Need to look at the ions. Right, now I could do the same reaction, but instead of using metal hydroxide, I can use a metal oxide. So same acid. Now I'm using, instead of sodium hydroxide, I'm using sodium oxide, Na2O. It's not the same thing, but the products will be the same thing. Okay? I will still get water, and I will still get the same salt, Na2SO4. Okay? So that's why you can count as 2 kind of reaction or 1 kind of reaction. Okay? It's up to you. The second or the third reaction, which is the second neutralization reaction, is where we take acid and react it with a metal carbonate. Not metal oxide, not metal hydroxide, metal carbonate. Okay, so what do we get here? We get water, as we did before. We also get the salt, but we also get the carbon dioxide. Remember, we got these bubbles and then they extinguished the fire, so that was carbon dioxide. So let's look at an example. I chose a different acid, phosphoric acid, H3PO4, reacting it with CaCO3. Carbonate is the ion CO3. So metal carbonate, CaCO3, you get H2O, you get CO2, carbon dioxide, and the salt is going to be made out of the metal, Ca, and the non-metal is PO4. Okay? PO4 has an ionic charge of 3 minus. Okay, so we'll drag the 3 over to the Ca. Ca has a charge of 2 plus, so we'll drag into PO4. Okay? So I'll pause here. Let's do some examples. Okay, guys, so I've got 4 examples here. And, the tricky thing in the test is that when I give you, I will give you something like this. Reactant of a reaction. Now, you need to complete, but you need to figure out which reaction is it. Is it the first one, metal and acid? Is it the second, acid, metal oxide or hydroxide? Or is the third, metal, acid and a carbonate, metal carbonate? So there's quite a lot of stuff going on here. So you need to recognize the acids. Okay? Now, I'm going to use just simple equations here just to make it quicker, but in a test, I can actually just give you the word equations as well. Okay? HNO3 is nitric acid. You react it with Li2CO3. Well, that CO3 is a carbonate, so you need to straight away realize that's the third reaction. It's an acid and a metal carbonate. What kind of products we have? The first two you don't even have to think about much. It's water plus carbon dioxide. Okay? The third one is your salt. Okay? So let's think about what makes the salt. It's a metal and a non-metal. Okay? So your metal bit is always hiding in the what do you call it? In the base. Okay? So it's Li. Now, the non-metal, let's give it another color. The non-metal will always be hiding in your acid. Okay? So it's a combination of Li and NO3. Let's write it in green. Li and NO3. Now, I personally first will just write like that. Now I need to figure out the ratio. Li is your first column. It's group 1, so it's plus 1. NO3, you need to remember, is minus 1. The ratio works. Okay, it's LiNO3. Okay? Right. Let's just finish it now. Okay? So, until now, we kind of say, okay, we'll just write them like this, but we're not going to balance. Okay? Remember we said that? Now we got to balance. Okay? Because as chemists, okay, we cannot be satisfied with the fact that there's Li2. There's 2 atoms of lithium here and only 1. That's just not good enough. Okay? It was all right for now. Now we need to balance it. Okay. So the first step I would do is, well, there's a bunch of stuff here, and wherever you start, it's not essential, but I would start with saying, I'm just going to rub this if you don't mind. It annoys me. And get rid of this as well. Okay. All right. So I've got 2 lithium, and I only have 1 here. How do we fix it? Can I write 2 here? No, of course I can't. Then I'm changing the molecular structure. Okay. I only have 1 lithium on each NO3. If I want 2 lithiums, I must write the big 2 before that. But then, I got to say, okay, if I've got 2 lithiums, that means I have also 2 NO3s. That means 2 nitrogen and 6 oxygen. I have only 1 NO3 here. So I'm going to have to put 2 over there. And then there's 2 NO3s and 2 NO3s. You see, I'm counting the NO3 as if it's 1 atom. Of course it's not. But I can count it as if it is, because I've got 2 N's and 6 O's. So that's fine. Now I need to look at the rest. So I've got oxygen. I've got 3 here, okay, 3 here, okay, I've got 3 oxygens here, and I've got another 6, I've got 9 oxygens here, I've got 9 oxygens, okay, and that's a little bit of a problem, because here I only have, how many do I have here? I have 6 oxygens. Sorry, I don't want to count these. Okay. I'll just stop here for a second. Because I count the NO3s here as 1 unit, I'm not going to count these oxygens separate because I've got 2 NO3, so that's fine. So I'm just going to say, all right, I've got 3 oxygens here, and I've got 2 plus 1. There's also 3 oxygens there. So that's actually good. That's actually good. Okay? Right? If I want to count all the oxygen, you can. Look. 2 times 3 is 6. 6 plus 2 is 8. 8 plus 1 is 9. Okay, so we 9 oxygen on this side. Here we've got 6 oxygen. Here, plus 3 is 9. So it works out well. Either way it works. Okay? I need to check hydrogen. 2 hydrogen. Okay? And I've got 2 hydrogen. Okay, fantastic. The last atom we didn't look at is carbon. 1 carbon, 1 carbon. Good, that's balanced. Okay, guys. See, balancing is a bit tricky. But the good side is, if you wrote the reaction, but you didn't balance it correct, you probably lost 1 mark. Okay, I'm not going to give huge weighting for the balancing, because I know it's tricky. Okay? Guys, I'll pause you here. Well, I'll stop the video here, because it's getting a bit longer. And I'll do those on a different video. See you in a bit. Don't go away.